You are warmly welcome once again. In this video, we are going to look at the third type of variation. In our last class, we looked at direct and inverse variation. Today, we'll be dealing with joint variation. Joint variation. As the name implies, something that is joined, it simply means a quantity. It jointly varies with two or more other quantities. A quantity can vary directly with two or more other quantities, or a quantity can vary directly and inversely with other quantities, or it can vary inversely with two or more other quantities, depending on what we are asked. Let us see some worked examples on how we solve joint variation. We are told x varies directly as y and y varies directly as z squared. How does x vary with z? Well, we can say this question is for fun. It's more or less a logical question. It's like saying if A is equal to B, B is equal to C. What is the relationship between A and C? Of course, we know that A will be equal to C. So it's the same thing here. So if x varies directly as y, that's one expression. Then y varies directly, not z squared. Y varies directly as z. That's the second expression. It therefore implies by logic that if x varies directly with y and y varies directly with z, that x varies directly with z. This is just to warm our minds up. Okay. Then let's look at another question now. Let me write it under, just in case you're writing the first question. Second one says x varies directly with y squared and sorry, this is not the one I intended. X varies directly with y and z. When y equals 2 and z equals 3, x equals 30. Okay. Find the relationship between x, y, and z. X, y, and z. Then question B. See on this number 2. Find x when y equals 4 and z equals 6. Now, this is another simple question. As we can see here, we see that the quantity x varies directly with two others, y and z. The approach we use in solving joint variation is exactly the same we have been using before with direct and inverse variation. So the steps are the same. So x, we are told, varies directly with y and z. The next thing, I guess you are right, introduce your constant k. That will be x equals k y z, where k is a constant. So look for k from here. We divide both sides by yz. So now become kyz over yz equals x over yz. Why will take yz, take z here. We therefore have k equals x over yz. Yeah, so we have made k the subject of the formula now. Now let's find the value for k using the first set of values where we are giving values for the three quantities. We are giving y is 2, z is 3, x is 30. The purpose of this is to enable us find k. So let's substitute them into this relationship now. We are going to have, so when y is 2, z is 3, and x is 30. So it should now be k equals x is 30 over yz. That's 2 times 3. 3 here, 1. 3 here is 10. 2 here, 1. 2 here is 5. So the value for k is 5. We now know the value for k to be 5. After you obtain the value for k to be 5, our next step, I guess you are right again, is to find the law of variation. Now, to do this, we have to recall the point where we introduced. We have to recall the point where we introduced our value for where we introduce k rather. So that will be x equals what? K yz. X equals k yz. Our value for k is 5. So therefore x will be equals 5 yz. This is the law of variation, or law of proportionality, or the relationship between x, y, and z. We are now set to answer the two questions we are asked. The first question says, find the relation. Okay, we have answered the first question now, which is question A. We have answered the first question. Find the relationship between x, y, and z. This is the relationship. Question B says, find x when y is 4 and z is 6. So when x we don't know, y is 4, z is 6. So from this equation, which is x equals 5yz, that will be 5 times y is what? 4, z is what? 6. 5 times 4 is 20. 20 times 6 is 120. That's the answer. That's the solution to it. So you see that the approach is the same with direct, base, and joints. The same thing. The same thing. Which makes it easy and simple. Let's look at the second question. The third question rather. The third question. The third question says the energy E varies directly as the resistance arrow and inversely as the square of the distance d. A. Obtain an equation connecting E arrow and D. Obtain an equation connecting I guess we are finished writing this. E arrow and D. Then B, if E equals 1.28 when arrow equals 8 and D equals 5, calculate figure 1 the value of arrow when E equals 16 and D equals 3. Roman figure 2, the value of D when arrow equals 5 and E equals 5/6. Usually when students see a long question like this, you scream. Don't scream. The steps are the same. Write out the relationship that is connecting the three quantities, number 1, and that is just what we are going to do. Let me clean this up now. I guess you've had the question in your notes already. So I will clean this so that we can look at it gradually. Question A. says obtain an equation connecting E arrow and D. Now, the equation that is connecting E arrow and D is from the first information we are given. The quantities here are the energy E varies directly as the resistance arrow and inversely as the square of the distance D. That's the relationship that is connecting, that's the equation rather that is connecting E arrow and D. That's the equation connecting E arrow and D. B says if E is 1.28 when arrow equals 8 and D equals 5, we have not obtained the law of variation. That means we have to introduce our constant K, then find the law of the variation. So we have that E is proportional to arrow over D squared. So this implies that E equals K arrow over D squared, where K is a constant. Where K is a constant. Now let's look for the value for K out. That's by making K subject of the formula. So from E equals K arrow over D squared, if we cross multiply, we have that K arrow equals E times D squared. We divide both sides by arrow. We have K arrow over arrow equals E D squared over arrow. Arrow cancel arrow here. That leaves us with K equals E D squared over arrow. Now let's obtain the value. We have made K subject of the formula. The next thing is for us to obtain the value for K. We are given the first set of values for all of them. Look at the question. We are told that E equals 1.28, arrow equals 8, D equals 5. So let's substitute them here. That will now give us K equals 1.28 times 5 squared over 8. 1.28 times 5 squared over 8. I'm sure you have taken this down. So that will be K equals 1.28 times 25 over 8. Now if you observe, there's a decimal point here. I want to turn this 1.28 into a whole number. It's going to affect the value of the denominator. So when I move the decimal point out 2 times, 1, 2, I will add 2 zeros here. That becomes 128 times 25 over 800. So let's cancel that now. 5 here is 5. 5 here is 160. 5 here is 1. 5 here is 3. 2, that's 32. Then we have 4 here is 8. 4 here is 32. We now have 32 over 8. 8 here 1, 8 here is 4. So therefore our value for k is 4. Our value for k is 4. Having obtained the value for k, it is now easy to write the law, or the law of the variation. We want to record the point where we introduced our k. E equals what? K r over d square. So it is going to be E equals 4r over d square. This is the relationship or law, relationship between E, r and d square, or the law of variation or law of proportionality between E, r and d square. From this line, we will now be able to solve the two questions we are asked, Roman figure 1 and Roman figure 2. Let me give you some few seconds to take this. Okay, I believe we have quickly taken that down. So let's look at Roman figure 1. When arrow we don't know, E is 16 and D is 3. When E is 16 and D is 3. So from this relationship, we have E equals 4r over d squared. Our E is 16 equals 4r over d is 3. That's d squared. That gives us 16 equals 4r over 9. Now we are looking for arrow. Let's cross multiply. We cross multiply, we have 4r equals 16 times 9. If we divide both sides by 4 so that we can leave arrow as the subjects, we have 4r over 4 equals 16 times 9 over 4. 4 will take 4 here. 4 here, 1. 4 here is 4. So therefore, r equals 4 times 9, which implies that r equals what? 36. Yes, r is 36. You can see here. So you see the approach, the same. Steps are the same. It's as easy as that. I hope I'm easing your mind down on this topic, variation. Now let's look at the second question. let's look at the second question. Roman figure 2. We are given the value, we have to find D, we don't know. Arrow is 5. E is 5/6. So from the law of variation, we have that E equals what? K arrow or 4 arrow over D square, rather. So here we are giving E as 5/6 equals arrow is 5. Then we are asked to find D square. So that is 5/6 equals 4 times 5 is 20 over D square. We multiply both sides by the denominator, 6D square, or we can cross multiply, whichever way we want. Let's cross multiply. Five times D square is 5D square equals 6 times 20. Divide both sides by 5. We are going to have 5D square over 5 equals 6 times 20 over 5. 5 will take 5 here, 5 here 1, 5 here is 4. So we have that D square equals 6 times 4, which implies D square equals 24. Now, if you stop here and say D square, your answer is 24. You have failed it. Why? What are we looking for? D, not D square. So, what are we going to do now? How do we go about this? It's easy. To remove this square, we are going to take the square roots of both sides. Following the law of indices, the square root will cancel this square out. So let's do that. So we are going to have, so we now have what? D square equals 24. We are looking for D, not D square. So we square root both sides. When we square root both sides, we now have square root D square equals square root 24. The square root will cancel the square, leaving D. The square root of 24, you can use a calculator to check that out, or your 4-figure table. Square root of 24, we have the value as 4.8989. 4.8989. That will be D. We approximate to the first significant figure. D will be equal to 5. Always show your approximation so that your examiner will know what you did. So one significant figure. So we've gotten our answer. That's the solution to the third question. So as we can see, the approach in solving joint variation is easy, is clear, and it's the same. In our next class, we are going to look at partial variation. I hope you join me in that next class. Until then, please press the subscribe button. Thank you very much. Yes.